Hello viewers, I'm Kausalya. Today we are going to solve problems related with oral transients. The problem is, in the circuit shown in figure, switch S1 is closed at t equal to 0 and switch S2 is opened at t equal to zero point 0.2 seconds. Find the expression for the transient current for the two intervals. So here, this is the given circuit diagram, right? So in the given circuit diagram, here there is nothing, okay? This is the given circuit diagram and this circuit has two switches, okay, S1 and S2. So what is the case? You see, switch S1 is closed at t equal to 0 and switch S2 is opened at t equal to zero point 0.2 second. What does it mean, right? That is, when t is equal to 0, both the switches are closed, right? When t is equal to zero point 0.2, switch S2 is kept open. So the first thing is both the switches are in closed state. So when both the switches are in closed state, how does the current flows? You see, current from this 100 voltage source, okay, flows like this. Now tell me at this junction whether the current will flow through this 50 ohm or it will flow through this switch, because both the switches are closed. So here what happens, as we all know, the current will always select the least resistance path, right? Therefore, the current flowing from this 100 voltage source will flow through this S2 and it will flow through this 10 ohm and this 1 Henry and it will finally end up with the source here, right? Therefore, here this 50 ohm is bypassed. So, while writing the expression, you see, so here the current flowing is, let the current be I of t. So while writing expression 10 into I, right, plus L into di by dt. Here the value of L is 1. Therefore 1 into di by dt is equal to 100, right. This expression is written as per KVL, that is voltage rise is equal to sum of voltage drop, right. And initially there is no energy is stored in the inductor. That is the reason here I of 0 is equal to 0. So as we all know, the expression for current is given by I is equal to I into 1 minus e to the power minus R by L t, right. And this I is nothing but E by R. So here what is the value of E? It is 100, and what is the value of R? It is 10. Right. So in this case, the value of R is 10, L is 1. So just substitute. And finally, this is our expression for current. Right. I is equal to 10 into 1 minus e to the power minus 10t. So this is your expression for current. Right. Now the next thing is, when t is equal to 0.2 second, we are opening our switch S2. Right. So at t equal to 0.2, we are calculating what is the value of current. So in the place of t, just substitute 0.2 and finally you see the current that flows is 8.65 amps. Right. Now we are going to open our switch S2. So again we will look at the circuit diagram. When you open the switch S2, what happens? So the current coming from this source voltage will flow like this and it will flow like this and finally it will end here. Right. So while writing expression, you have to consider this 50 ohm also, and again you see these two resistors are connected in series. Therefore 60 I, right, the voltage drop across the resistor is 60 into I. So here you see it is 60 into I plus L into di by dt dash. That is, in order to show the difference, here we are representing t as t dash, again which is equal to the total source is, it is equal to 100 volt, right. So here I of 0, that is the energy stored in the inductor, right. I of 0 is equal to, that is 8.65 amps. So this is what we have calculated previously, right. So I of 0 is 8.65 amps. This is the current which is caused during the initial stage, that is when both the switches are closed, right. Now when the switch S2 is open, our expression gets modified like this, and now we are going to take Laplace transformation. So you take Laplace transformation, as we all know, di by dt becomes dt dash. When you take Laplace, it becomes s into I of s minus I of 0, right. So here again In the place of I of 0, we have calculated it is 8.65 amps. So just substitute it over here. And finally, we have to find an expression for I of S. So here, you see, we are moving this 8.65 to the right hand side. So it becomes plus. And again, we are taking LCM. And finally, our expression for I of S is given like this, right? 100 plus 8.65 is divided by S into S plus 60. So again, by partial fraction, we are finding the values. So here we are having two terms. So we are splitting this expression as two parts, A by S plus B by S plus 60. So here we are taking LCM. When you take LCM, you see both the denominator terms cancel each other. Our aim is to find the values of A and B. So to find the value of A, just substitute the value of S as 0. When you substitute S as 0, 0 into B becomes 0. Right. So here the value of A is calculated as 1.67. Similarly, to find the value of B, we have to make this A part 0. So in order to make this A part 0, you see here we are having 60. So when you substitute the value of S as minus 60, then this becomes 0. That is the A term becomes 0. We can easily calculate the value of B. Right. So here, just substitute the values and finally the value of B is 6.98. Right. Now substitute the values of A and B in the expression of I. So I of S is given by this expression. Right. So but we need I of T. Right. In terms of T, that is transient current. So here when you take inverse Laplace, what happens? 1.67 by S becomes 1.67 and this 6.98 as such, and S plus A, this is given by e to the power minus at. So here it is T dash. Right. So this problem gets over here. We will proceed with the next one. So our next problem is find the current in the circuit shown in figure at an instant t. After opening the switch, if a current of 1 amps had been passing through the circuit at the instant of opening. So here in this case, you see, we have to calculate the current in the circuit, okay, at a particular instant t, right, after opening the switch, right. So initially the current that is flowing through this circuit is 1 amps, okay, that is I naught. So now we have to calculate the current value when the switch is kept open, right. So here in this circuit, you see the typical thing is here we are having two voltage sources, right. So one is 12 volt and another one is 24 volt. So when you keenly observe, you see when you kept this switch open, how does the current flows through this circuit? You see, current flows from this 12 volt, it will go like this and it will go like this and again it will go and finally it will end up here, right. So in this case, since we are having two voltage sources, either we have to add those two sources or we have to subtract. So how does we can do that? You see, when you look the direction of current, here it is minus to plus, right. And similarly again here it is minus to plus. So since the polarities are same, here we have to add these two voltage sources, right. So 24 plus 12, that gives 36 volt, right. Again the same thing when you write the expression, when you apply KVL for this circuit. So what is the basic expression? It is given by I into R plus L into di by dt is equal to E, right. So just now we have find out, right, the value of E is, you have to sum up. Therefore the value is 36 volt. And the initial current, it is I of 0 plus is 1 amps, right. So now we have to take Laplace transformation for this equation after substituting the values. So here substitute the values of R, L and E. So when you substitute the values, this is our expression, right. So the next step is we have to take Laplace transformation. So when you take Laplace transformation, 6 into I of S plus 5, when you take di by dt Laplace, that gives S into I of S minus I of 0 plus, which is equal to, this 36 becomes 36 by S, right. So here again I am taking I of S term outside. So when you take I of S outside, the remaining terms will be 6 plus 5s, right? And here 5 into I of 0 plus is 1. So here I had written 1 into 5, right? The next step is I am going to move this 5 to the right hand side. So here that becomes 36 by s plus 5, and if you take LCM, here is our expression, right? 36 plus 5s by 5. So next, as usual, we have to find an expression for I of s. Then the next step is, as it has two terms in the denominator, we have to split and write it as two individual terms. Okay, a by s plus b by 5s plus 6. So just take LCM, and here the common terms, denominator terms cancel each other, and finally we are having an expression like this. So again, in order to find the values of a and b, we have to substitute the values accordingly. So first substitute the value of s as 0 so that b becomes 0. We can easily find a. So here the value of a is 6. Similarly, in order to make this term a 0, here we are having plus 6, right? So this term should give minus 6 so that a cancels, so that a becomes 0. So how to find a value? What is the term which we have to substitute it here? So just divide 6 by 5, right? That gives the answer. When you divide 6 by 5, here the answer will be 1.2. Right. Here this 6 is with plus sign. Therefore, we should have this 5s with a negative sign. Therefore, minus 1.2 here. So just substitute the values, and once you solve, the value of b is minus 25. Right. Now just substitute the values of a and b in the expression of I of s. So after substituting, you see, the basic thing is we have to take inverse Laplace. In order to take inverse Laplace, the denominator term should be in the form of s plus a, right? That is the reason why here 5 is taken outside. So when you take 5 outside, what happens? Here this term becomes s plus 6 by 5. Right. So 25 by 5 is 5. Therefore, 5 divided by s plus 6 by 5, and 6 by 5 is nothing but 1.2. Right. So here this is our expression for I of s. So therefore, when you take inverse Laplace transformation, we can find an expression for I of t. Therefore, I of t is given by 6 minus 5 into, that is s plus a is e to the power minus at. So in the place of a, I am having 1.2. Therefore, e to the power minus 1.2 t. So this is our expression for transient current. Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.